subject problem solving and C programming. So I am Dr.D.KIRUBA JOTHI, Associate Professor, Department of Computer Science and Engineering, PSN College of Engineering and Technology. So today I am going to discuss the basic concept for computers. Okay. So before of that, I want to explain the expansion of computer. So many of them, what is computer? They are knowing only the definition for computer, but they are not knowing the abbreviation for computer. So now I am going to tell the abbreviation for computer. So C for common, O for operating, M for machine, P for purposely, U used for, T technical, and E for educational and research. So this is the expansion of computer. So basically we all know about who is the father of computer. Yes. So in school day itself we know that who is the father of computer. So the father of computer is Charles Babbage. So can anyone know about who is the first programmer in computer? So no, because we are only knowing who is the father of computer. So I will tell you later. So the Charles Babbage is the father of computer who invented the computer in the year of 1791 to 1871. He is not also the father of computer. He is also a good mathematician, inventor, philosopher and mechanical engineer. So that's why he invented the computer, because he well in all the subjects as a mathematician, philosopher and mechanical engineer. So that's why he invented the computer. Okay. So then history of computers. So in previous years the peoples are count the numbers. So how they are count the numbers means they are using sticks, stones and bones and counting tools. So the tools are to count the number of devices. So after that only to count the numbers, the Charles Babbage invented the computer. So that is the device. So as human mind and technology improved with the time, more computing devices were developed. So before of that, they are using to count the number of items by using only sticks, stones and bones. Then the peoples are invented calculator. So after advanced, the peoples are using the computer devices. Yes. So before of that, the peoples are invented abacus. So the abacus is also used to calculate the numbers. So using abacus, we can only calculate the addition, subtraction, multiplication and subtraction. So these many operations only we can calculate it by using the device abacus. Then Napier's bones. So this is also one of the counting device. This device is invented for the same manipulation, addition, subtraction, multiplication and division. So this was invented by John Napier. So it's able to do multiplication much faster than abacus. We can compare than abacus and Napier's bones. So this is faster than abacus. Then the peoples are invented difference engine. So this difference engine also do some of the mathematical calculations for only addition, subtraction, multiplication and division, as well as some polynomial calculations and logarithms also calculated. Then after that, the Alan Turing. So Alan Turing is the father of computer science. In our college is also having one laboratory name is Alan Turing Lab, because he is the father of computer science. So that's why our lab going to give the name is Alan Turing Lab. So the Alan also is not a father of computer science. He is also one of the English mathematician, logician, cryptanalyst and computer scientist. So father of computer science and artificial intelligence. So in the year of 1912, from June 23rd, 1912 to June 7, 1954, he invented the computer science technology. So he introduced the Turing machine. So the Turing machine look like this. So this is a diagrammatical representation for Turing machine. Then she is also one of the most popular in computer science engineering. There is Ada Lovelace. In the year of 2019, he was the first computer programmer. So she wrote first program in computer science and engineering. Her name is Ada Lovelace. In the year of 2019, he only wrote the first computer programmer in computer science field. So these are all the basic inventors in computer science and engineering. So Charles Babbage is the first father of computer. Then Alan Turing, so he is the father of computer science. Ada Lovelace, he is the first computer programmer. So all the computer science peoples must know all these inventors' names. So now I am going to discuss the generation of computers. Now we are going to use the computers as 5th generation computers. Now we are going to use, that is AI, artificial intelligence computer. For the first generation of computers was invented from 1940 to 1956. In first generation computers, the peoples are using vacuum tubes. Then the second generation computer looking like this. So this was invented the year from 1956 to 1963. The peoples are using for transistors to convert all the information into binary format. The peoples are using the translators as transistors. Then the third generation computer. So third generation computers invented from 1964 to 1971. Here the integrated circuits. The circuits are used to translate all the human level languages should be converted into machine level languages. Then the fourth generation computers. So these computers, all the peoples are knowing this type of fourth generation computers. This was invented from 1972 to 2010. So here microprocessor techniques used. Then nowadays the peoples are using 5th generation computers. So this was invented from 2010 up to 2010. Now current year we are going to use the 5th generation computers. Here we are going to use the AI technology. Okay. So now I am going to definition. So now I am going to discuss the correct definition for computer. So already we discussed what is the abbreviation for computer and who is the inventor of computer, then father of computer, then who is the first programmer. So now we are going to discuss the definition for computer. So already we know that what is computer. Computer is an electronic device. Now here if you want to solve any of the problems or any of the tasks, we are going to interact with the computer. So what we are going to do by using computer? We are going to feed the inputs to the computer. The computer process all the instructions and return back to the output into the user. So this is the process for computer. So that's why we are going to define the computer as an electronic device. This will accept the input data and process it according to the instruction from software programs, stores information and produces the output. So not only the computer produces the output, and also the output should be stored in your computer. So how the instructions executed means by using some of the softwares. Either it may be application software or system software. If you want to produce the application oriented output means we are going to use the software name is application software. But application software is only depending upon the user requirements. So depending upon the user requirements, we are going to create the software. That software name is application software. Without knowing the languages, we can easily create the application software. But system software, so once we are going to study the proper languages and the procedures, then only we are going to create the system software. So based on the user requirements, we are going to create either the application software or system software. So after producing the output from the computer, we must store the information. Why we are going to store all the information in your computer? Because no need to again we can solve the same task or we can solve the same problem. That's why we are going to store all the information in your computer. For example, what are the data we are giving to the computer means either it may be words, numbers or images. Any one of the input we are going to feed into the computer that will perform the logical operations and store information for future use and display the results for humans to see, making it a fast, accurate and multitasking machine for various tasks. So why we are going to contact the computer means this will reduce the human workload. So that's why we are going to communicate the device. So the device will reduce the time consuming, the time from the user. So that's why, the main thing is we are going to solve more than tasks at the same time. We are going to finish, we go to contact the computer, that is electronic device. So this will reduce the time. So that's why we are going to contact the computer. So this is the diagrammatical representation for calculator and computer. So before invention of computer, we used the calculator for calculating the addition, subtraction, multiplication and division. But calculator is not having the memory space. So that is the difference between calculator and computer. Calculator only for calculating the addition, subtraction, multiplication. That's it. But computer will do so many tasks. So next we are going to see the components and functions of computer. What are the main components and functions in computer? First one is input devices and central processing unit, storage, output devices and software. Without any one of these key components, we can't perform any of the tasks. So each component is very essential for doing the task. So first one is input devices. So input devices in our computer, they are having so many input devices. So some of the input devices are keyboards, mouse, sensor. So these are all the external sources connected to the computer. Why? Because this will feed it into the computer. This will give the input. We are going to use these external sources. We are going to feed the information or raw data to the computer. So that's why we called as the device name is input devices. We are going to feed the input. Either it may be keyboard, mouse or sensor. Then another one is once we are giving the input to the computer, we must execute it. So in execution process depending upon the central processing unit. So simply we called as the name is CPU. So the CPU is the brain of the computer. So this will execute the instruction from the software to process is the input. So this will fetch all the input from the input devices, then it will execute it with the help of central processing unit. That's why we are going to call it as the CPU is a brain of the computer. So in execution, either we can use various types of softwares. Then storage. So storage is very essential. The computer stores all the data and information in digital format. So digitally, devices like, so either we can store all the information in your hard disk, any of the devices, we are going to store it, the results. Then output devices. Finally, we are going to show the output. So we are going to display all the outputs by using the devices, either it may be monitor or printer or any one of the display hardware devices. This will help to showing your final output or final information. Then software. So already I told the software, it's either it may be application software or system software. So software is nothing but is a program or set of instructions. This will tell the computer hardware what tasks to perform and how to perform them. So the software will instruct the computer how to perform and what task or how we can solve that the particular problem. So the main thing is software. Okay. So depending upon the software, we are getting the good result. So these 5 components are main for your computer. Then how the computer it works. So already we discussed in the previous slides. This will get the input from the hardware or input devices. Then it will execute the particular task by using the central processing unit. Not only we are going to execute the data, and also it will store the results. Some of the memory devices we are going to save all the information. Then after executing and storing the information, we must display it. So some of the output display devices used to show your results. So this is the pictorial representation for central processing unit. So we are giving the input to the central processing unit. Then the central processing unit execute all the tasks. This will produce the output. So inside the central processing unit, it contains some of the control unit, arithmetic and logic unit, then memory unit. The combination of all the control unit, arithmetic logic unit and memory unit. This is a combination of central processing unit. So this architecture name is von Neumann architecture. So this is a computer. So this will connect so many input and output devices like CPU, speakers, keyboard, mouse, flash drives, printers and webcam. So these are all the combination of input and output devices. Then we are going to discuss the different kinds of computers. So depending upon the user's performing task, we are going to choose either it may be the computers as personal computers, servers, mainframe computers, supercomputers, embedded systems and mobile devices. So based on your task, we are going to choose which computer is best one. If suppose we are going to only for individual or general use, we go to use or we go to choose only personal computers. Okay, so we are going to do a simple task. We are going to purchase the desktop, laptop, tablets and personal computers. That is enough. If suppose we are going to hosting the websites and collecting the data and do some applications, we are going to choose the computer is name is servers. So the servers, this will manage and distribute the network resources. So no need for a single or individual purpose. We don't go to purchase the personal computers. If you want to manage the network resources, that time only we are going to purchase the servers. All the institutions they are having the servers, because this will manage and distribute the network resources all the single computer. So this will connect all the computers in a single server is a middle of the computer. This will connect so many computers. This will distribute the network to each and every computer. So that's why we are going to fix the servers in all the educational institutions. Not only educational institutions, we are going to use various companies, because this will distribute the network resources from server to other computers. Okay, so then is mainframe computers. So the size is very large and the expense also high. So that computer name is mainframe computers. Why? Because mainframe computers is very large and expensive, means this will perform the task like financial transaction and census data. If you want to calculate the census in our country, or we are going to find the financial transactions, we go to use the mainframe computers. So the mainframe computer is to find the financial transactions and census data. The peoples are using mainframe computers. So all the government employees are using to solve the financial transaction and census data. The peoples are using mainframe computers. Then supercomputers, compare them all the computers, this is fastest and most powerful computers. Why? Because this will go to find the weather forecasting and all the scientific research calculations and complex simulations. The peoples are using supercomputers, because this will run or execute all the tasks in fastest mode. So this one is most powerful compared than the other computers. Then embedded system. So embedded system is very small in size and specialized computers built into other devices. For example, cars, appliances and smart TVs. The peoples are performing all the tasks by using embedded systems. Compared than all the computers, the size is very small. Then mobile devices. Nowadays all the peoples are having the mobile devices. Here this we are calling it as portable computers. The mobile devices, the another name is portable computers like smartphones and tablets. The features touch screen interfaces and wireless communications. So without wire, we are going to communicate the internet in your mobile devices. So this is one kind of portable computers. So how we can classify all the computers? Depending upon their size, power and purpose. So based on the user requirements, we are going to choose any one of these computers. So this will classified based on the characteristics of size, power and purpose. Now I am going to show the diagrammatical representation for different types of computers. So here we can classify 10 different types of computers. So this is mini computer, mainframe computer, supercomputer, hybrid embedded computer, analog workstation computer, server computer and laptop. So these are all the picture representation for different kinds of computer. Then different kinds of hardwares should connected to the computer. So LCD monitors, laptops, keyboard, mouse, speakers, graphics and sound cards, then headphones, then UPS, wireless routers, memories, DVD, motherboard, then external hard drives, then different kinds of printers. It may be inkjet, laser, then multifunction printers and scanners. Then CPU, fan, RAM. So these are all the devices. This will presented inside the central processing unit. Power supply, DVD, motherboard or main board, CPU, fan, RAM, VGA card, sound card, hard disk, reader, all in one internet. So all these devices are presented inside the cabin, that is called as CPU, Central Processing Unit. So this is also different kinds of input and output devices. So now we are going to classify the softwares. So what are the classification of software available in your computer means? So first we can classify the software. It may be system software or application software. Then the system software further divided into two types, that is system management and software development. So system management means the example for system management: operating system, device driver and utility program. So all these softwares comes under the system management. Then software development. If you want to develop any one of the software, we can use either it may be linker or loader, debugger and language processor. So these are all the software development tools. Then application software. So application software may be general purpose or specific purpose. Based on the user need, we are going to use the application software for the general purpose or a specific purpose. In general purpose, all the peoples are normally using word processing, spreadsheet presentation and browsers. Then specific purpose means HR management, payroll system, attendance system, railways reservation system. The peoples are using the software for the specific purpose. So these are all the pictorial representation for different types of computer software. Then the utility program also further divided into three types: file management, disk cleanup and virus cleanup. Language processor further divided into compiler, interpreter and assembler. So now we are going to discuss one by one for the next slides. So before introducing the software, now I am going to discuss what is operating system. So we are simply call it as the operating system name is OS. So OS is the fundamental software that manages the computer's hardware and software resources. So the operating system acting as an intermediary between the user and the computer to perform the task. So what are the tasks we are going to do by using the operating system means this will perform the memory management, process scheduling, file management, handling input and output devices, enabling users to run applications and interact with the system without needing to understand the computer's complex language. So if you want to use the computer, first we are going to do the first step is we are going to install any one of the operating system in your computer. So either it may be the operating system Windows, Macintosh, Linux for desktop or laptop. So if you want to install the operating system in your computer, we are going to choose either it may be Windows, Macintosh, Linux and Unix in your computer. For mobile devices, so all the peoples are using the operating system name is Android, iOS, any one of the operating systems we are going to install in the mobile devices. So this operating system is a main role to communicate between the user and the computer to performing the task, or it used to solve the human problem. So that's why before using the computer we must install the operating system in your computer. So this will manage all the computer hardware devices and software resources. So the fundamental software is operating system. So this is the architecture for operating system. We are going to communicate between the user and the computer with the help of operating system. So either it may be the software application or system software. So this is a brief diagrammatical representation for operating system. So not only we are going to communicate only one user, we can communicate more than n number of users. We are going to communicate the hardware with the help of software. The software name is operating system. Okay, then next, what is the key functions of an operating system? If you use the operating system, the main components are a resource management, user interface, application interaction, file and process management. So what are the key functions in operating system means? First one is resource management. So what is the use for this resource management is this will ensure the resources are shared efficiently. So this will test your resources. So then only it will approve the particular resources to the computer. For example, it will manage the central processing unit, memory, storage and all the input-output devices. That is the first step. We are going to manage the central processing unit, memory, storage and all the input-output devices shared efficiently among the various programs. So after checking all the resource management, the user interface will be started. This will allowing the users to interact with the computer and run the applications. For example, it will run the applications, web browsers, word processor and games. So once the resource management will be checked, after that it provides a user-friendly interface. This will allow interact with the computer and run the applications. For example, the applications are web browser, word processor and games. Then application interaction. So the operating system enables the applications to run and performing the task by providing an environment. So the environment is very must to perform the task is depending upon your application usage. Then file and process management. So file and process management, this will control the operations and manages the execution of processes and handles communication between different programs. Then why the operating systems are important means without operating system platform we can't do any one of the tasks. So the operating system is very important. So this will reduce the human working time. So how we can choose the operating system means these two criteria is very important. One is convenience and efficiency. So convenience means this will make the complex computer system convenient to use by providing easy to navigate the interface, and efficiency, all the hardware resources are effectively, we can choose all the hardware resources effectively, or it may be make the error. If we are going to choose wrong hardware resources, this will make the error. So we can choose all the hardware resources are effectively. Then only the operating system optimizes the use of computer's hardware for better performance. We want to get the good performance or good result in your computer, we must install the proper operating system in your computer. So without an operating system, none of the applications could not run. So the operating system provides the necessary platform and support for all the software to function. This is the logo, that is the pictorial representation for all the operating systems. So this is Windows, Macintosh, Linux, Chrome's operating system, then Android, iOS, Unix and BSD. If you want to install the operating system in your desktop or laptop, we go to choose Windows, Macintosh and Linux. For mobile operating system, we are going to choose Android and iOS. Some of the specialized operating systems also used for ATMs, web servers and smartphones and supercomputers. So then next is language processor. So language processor is very important. So this is also one kind of system software. So using this language processor, we are going to translate all your human level languages or high level languages or source code. All the languages should converted into machine level languages. Machine level languages is nothing but is a binary format. So we must translate all the source code into binary code. Why? Because we are going to translate all the languages into binary code means the machine only can understand the binary format of inputs. So that's why we are going to translate the languages into zeros and ones. The computer knowing only the languages zeros and ones. The humans can only understand the alphabets and the Tamil letters and numbers, but in computer it only understands the zeros and ones. So three main language processor we are going to use to translate the source code into binary format. It may be a compiler, interpreter and assembler. So all these language processors should convert the high level languages into low level languages. For example, compiler C and C++, Java. So these are all the compiler languages. So here all the entire source code are converted into the machine code. Then interpreter, for example, Python, JavaScript and Ruby. So these are all the different examples for interpreter. So the interpreter also convert the source code line by line without producing a permanent executable file. So this will not produce the permanent executable file, but the compiler, this will produce the executable file. Because why? Because this will compile, at the same time this will translate the entire source code, but in interpreter this will compile line by line execution. So that is the difference between compiler and interpreter. So this will compile the entire source code at a time, but in interpreter this will execute line by line. So that's why this will produce the permanent executable file. Then assembler, we are going to use some of the mnemonic codes. The mnemonic codes are called as assembly level language. For example, add, if you want to add two numbers, we are going to use this mnemonic code ADD. So this will add two numbers. Then move, if you want to move from one to another, we go to use this mnemonic code. Then jump. So these are the example for assembler. So the assembly level languages, so this also one of the language processors should translate low level assembly level language, perform all the low level assembly language programs into machine level code. Then this is a comparison chart between the compilers and interpreters. So already we discussed in the previous slides. So for compilers this will translate the entire program, but interpreter this will translate only line by line execution. So this will create an executable file, but interpreter not produce the executable file. So here this execution is very faster compared than the interpreter. So the interpreter is a slower execution. So this will display all the errors after we are going to compile the program, but here we are going to stop the execution at the first error. So after correcting the particular error, then only we are going to compile the remaining source code. Here the more memory we are going to compile the particular program, it contains less memory. Then larger applications where speed and performance are critical, but here we are going to writing the scripting languages, smaller programs and environments focused on the fast development. So this is a comparison table between the compilers and interpreter. Then what is the role of a language processor means? First one is abstraction from hardware, error handling, code optimization, enabling portability. So once we are going to write the program, the error handling is very essential for detecting and reporting the particular syntax. Then code optimization. So after recovering or detecting the error, we can detect the errors and report the syntax. We must do the error correction. So the code optimization will do that work. So the compilers can analyze and restructure the code to improve the performance. We are going to recover the error. That's why the code it may be performing efficiently. Then enabling portability. So this will allow the same resource code to run on different platforms without modifications. Then first one is abstraction from hardware. This will we always write in low level languages source code. So that is very important. So all the programmers to write the source code in human readable high level languages without needing to know the complex details of machine code. So these are the four main things for the role of language processors. So here the interpreter, this will convert the high level languages into low level assembly language or binary language. So the compiler also doing the same work. It may be converted into high level languages to low level language. The assembler also convert all the computer instructions into binaries and zeros and ones. So this is also one of the pictorial representation for compiler. So this will fetch the source code as an input or a high level source code. This is your input. So all the high level languages or human level languages are fed into the compiler. This will translate the source code into machine level code. So thank you so much.